Welcome to part 2 of our video. This video will start with question number 3. Find the equation or an equation of the exponential curve that passes through the points 180 and 156 and a quarter. So what I'm going to do is I'm going to go ahead and label my coordinates. x1, y1, and x2, y2. So our first step is going to be to find b. And so I gave you this equation. And if you think you need this, then go ahead and add this to your note card. So we get b to the power of x2 minus x1 equals y2 minus y1. So I have 4 minus 1 for my exponent of b equals 156.25 divided by y1, which is 80. So this gives me b to the third power. And when I divide 156.25 divided by 80, I get 1.953125. So to find b, I'm going to raise both sides to the reciprocal of 3, which is 1/3 power. So when you do this, make sure that when you do the exponent, you put the fraction in parentheses. 1/3. And we see that b, we have an exact answer of 1.25. So b equals 1.25. And here is point ratio form. Now, y and x are going to stay as y and x when we write our equation. We can choose either pair for the x1, y1. Since I labeled this point as x1, y1, I'm going to go ahead and use 1 and 80 in my equation. So I get y equals 80 times b, which we found as 1.25, to the x minus 1 power. Now, as a check, you may want to plug in the other point to see if it actually works. So for this problem, I'm going to type in 80 times 1.25 to the power of, in parentheses, 4 minus 1. And I'm hoping I get 156 and a quarter. And I do. Okay, number 4. Armin is 30 years old and hopes to retire at 60. He wants to invest $10,000 in accounts, so the balance will be $50,000 when he retires. What is the annual percentage rate? Assume it's compounded annually. So here was our compound interest formula. So we know all of these numbers except for r. That's the rate we're looking for. So the end amount is given to us as $50,000. The principal, $10,000. We're looking for r. The number of compounding periods per year for annually is 1. And then 1 times t is just t. So to solve, I'm sorry, we do know t. My apologies. He's 30 now. He's going to retire when he's 60. So 1 times 30 is 30. So we get 30 there. So what I'm going to do is I'm going to divide both sides by 10,000. I'm just going to write that as 1 plus r, since r divided by 1 is just r. And I get 5 equals the quantity 1 plus r to the 30th power. Well, we want to figure out r, and r is inside the parentheses with 1 taken to the 30th power. So to get rid of this exponent of 30, or to make it 1, I'm going to take both sides to the 1 over 30 power. So I get 1.0551 equals 1 plus r. So solve for r. I'll subtract 1 from both sides. 0.0551 equals r. So r is about 5.51%. Make sure that doesn't look like a 7. Okay, number 5. Lucy bought a car for $23,000. The value of the car depreciates by about 17% each year. When will the value of the car be worth $10,000? So we know that right now, when it started, it was worth $23,000. And then it's decreasing at a rate of 17% per year. So we're going to write that as 1 minus 0.17. If you want to just write 0.83 there, that's fine. We don't know how many years it's going to be. And we know at the end it's going to be worth $10,000. So we'll go ahead and divide by 23,000 as our first algebraic step. And so we get 1 minus 0.17 to the t power equals, I'm just going to keep this as 10/23. Oh, so the variable we're looking for is in the exponent. Well, from part 1, you know that when we want to solve for a variable that's in the exponent, we'll simply take the log of both sides. So what that allows us to do is move the exponent to the main line of the equation. So to solve, we'll go ahead and divide both sides by the log of 1 minus 0.17. So t is about 4.47 years. So as a check, 23,000. 1 minus 0.17 to the power of 4.47. Now, when I push enter, notice I don't get exactly $10,000. That's because I used a rounded figure in my calculation. As long as it's pretty close, then your answer is probably fine. Okay, number 6, consider the function. Find the inverse. Okay, so notice it didn't write f of x, so we can kind of go to the second step, which is just replace, or swap, I should say, the x and y variables. So we did a problem like this on the warm-up earlier this week. So I'm trying to get y by itself, but it's inside parentheses with an exponent. So let's get everything but that expression on the other side of the equation. So my first step is going to be I'm going to add 1 to both sides. So I get x plus 1 equals 2 times y plus 3 to the 1/2 power. Then next, I'll divide both sides by 2. Which gives me x plus 1 over 2 equals y plus 3 to the 1/2 power. So to make this exponent 1, I will need to square both sides. Notice that 2 is the reciprocal of 1/2. So we get x plus 1 over 2 squared equals y plus 3. And we'll go ahead and subtract 3 from both sides. So that's part A. So part B, I'll just write up here. It says find the inverse with an input of 4. Actually, let's write that down here so we can see the equation. So I plug in 4 in for x. Gives me 5/2 squared. So when I square a fraction, I'm actually squaring both the top and bottom. So 5 squared is 25. 2 squared is 4. Now, you can do this in the calculator, but I don't mind doing a little fraction review. So if I want to combine these fractions, I need to find a common denominator. So I know that 3 times 1 is equal to 12/4. Notice that my special form of 1 was written as 4 over 4. So my answer is 13/4. Okay, then for C, the easiest part of it, find the function of the inverse of 6. Well, we know that inverses undo each other, so as long as 6 is in the domain here, and it is, I know that f of f inverse of 6 is equal to 6. Okay, then our last question. So we've got an equation in the form of y equals a plus b times the log of x that uses to find the cost of electricity. So we know that in the equation, 1 hour costs $7.44. So let's go ahead and plug that into our equation. So our cost is y, so $7.44. We don't know a, so we'll put a here, plus b, we don't know b, times the log of 1. Well, what is the log of 1? So really what we're asking is 10 to what power is equal to 1? And hopefully you realize it's 0. So this is equal to 0, which means a is equal to 7.44. Then we know that 3 hours have a cost of $18.36. So when I plug what I know back into this equation, I get y, which is $18.36. I know a is $7.44 plus b times the log of 3. So now I need to solve for b, and then I can write my equation. My recommendation is to go ahead and get the log expression by itself, or b times the log expression by itself. So I'm going to divide both sides by 7.44. I'm sorry. I don't know what I'm thinking. It's been a long day for Mr. Purcell. So let's take a break, take a deep breath. Of course, Mr. Purcell, you shouldn't divide by 7.44. You should subtract 7.44 from both sides. So 10.92 equals b times the log of 3. So now I can divide both sides by the log of 3. And that gives me b. So b is about 22.887. Okay, so that's part A. We have that, and we'll go back to here. What is the x-intercept of the model? And what is the meaning of the x-intercept? Okay, so the x-intercept is when y equals 0. So here's my equation. Y equals a, which was 7.44, plus 22.887 times the log of x. So when is y equal to 0? Well, we plug that in the equation, and we solve for x. So we'll subtract 7.44 from both sides. Negative 7.44 equals 22.887 times the log of x. And we'll divide both sides by 22.887. So to find x, we know that this is base 10. So 10 to the power of negative 0.3251 is approximately equal to x. So we type that in, and we get about 0.473. Okay, so what does that mean in context? Well, when y is 0, that means there's no charge. So you could say that the first 0.473 hours of electricity are free. Okay, so C, use the model to find the cost for 65 hours of electricity use. So here's our equation. So we'll go ahead and plug 65 into the correct variable, which would be hours. Type it in. We get about $48.93. And then for D, if a customer can afford $15, how long can he or she have electricity turned on? So we get $15 equals 7.44 plus 22.887 times the log of x. So to get the log of x by itself, we'll subtract 7.44 from both sides. It gives us 7.56 equals 22.887 times the log of x. We'll divide both sides by 22.887. So we know x is equal to 10 to the power of 7.56 over 22.887. So we get about 2.14 hours. Okay, that is it for the review. Good luck on the test.